Hi and welcome to C Programming. In today's lesson we're going to learn how to create dynamic memory by using two functions. Now the one function will enable us to create dynamic memory and the other one will help us to free dynamic memory. So we need to do both in every application where we create dynamic memory. We need to create it, but we must never forget to free that memory because it's dynamically created. It's created in the program, and if we just close the application without freeing that memory will still be allocated after the program or the application was closed. So that memory will be still allocated on your computer or device, and that memory will not be used by any other application because it's still allocated. And that means that you can run into memory problems in the future while that device or computer is still on. And the only way to solve that would be to switch off the computer or device and switch it on again. Because memory, for instance, on our computer, our random access memory, our RAM, it's volatile, meaning that when the power goes off, the memory is lost, so it's cleaned. So when we switch it back on, all the memory is lost. So if we run a program and we create dynamic memory, we allocate a space on our memory, our random access memory, for instance, on a computer, and that memory is then allocated. And when we close that application, that memory will still be allocated throughout the time when the computer is still on. And no other application will be able to use it unless we clean up the memory in some way or switch off the computer or device. So it's very important to remember not just to use the first statement to create dynamic memory, but also to close or free that memory so that it can be used by another application after that specific application was closed or program has finished. So let's jump into the coding and see how we can create dynamic memory inside C. So in code blocks we will create a new empty file. And we will start off by first saving our file as dynamic memory.c. So dynamic memory.c. And we will zoom in and we start with hash include stdio.h. And that's our standard input and output library. Then we will continue with our main function, open and close curly brackets, and we go to our return 0 statement. Then we save, we build and run to check that everything is okay. The C program compiled successfully, so we know we can continue. So now let's start and create dynamic memory. So how do we do this? Now, the way in C to create dynamic memory, we need something to point to that newly created memory. So when we create memory, something needs to point towards it. Otherwise, how would we work with it? It's like getting input from the user. If we get input from the user, that's nice. But how do we use it? We need to store that input inside a variable. And the same way, when we create dynamic memory, we can create it. But how do we use it? So we need something to point towards that newly created memory. Otherwise, we will not be able to work with that newly created memory. So, of course, if you heard the word point every now and again when I was talking about it, yes, you're correct. We're going to create a pointer. So we need to create a pointer that will point towards that newly created dynamic memory. So we have an int pointer variable. So that pointer variable will be able to point towards any integer variable. So we can go and then create a new integer. So the pointer will then point to a new integer. Great. So how do we do this? So first of all, we say pointer, that's our pointer variable, will be equal to. So it's now pointing towards something. And then we need to go and create new memory or dynamic memory. And how do we do that? So in C programming, the function that we use is malloc. M-A-L-L-O-C. So the malloc statement or function is memory allocation. So memory allocation function enables us to create dynamic memory. So this function will create then dynamic memory. But then if we just call the function, what will it create? We need to tell it we need to create something. And that something is, what do we want the pointer to point towards? A new integer variable or space or memory. So an integer, so we need to define the space size of the new memory that we want to allocate. So we're going to use a size of statement to tell the malloc statement that we want to create new memory the size of a integer. And that's it. So PTR is now pointing towards new memory created. Okay. But we cannot just assume that this statement will always work. Because let's say there is no memory to create new memory. There is not enough memory for the C program to dynamically allocate more memory. We have run out of memory. What do we do then? So we can use a if statement to say if pointer is equal to null. So that means that if the pointer is null, the malloc statement was not able to create dynamic memory. So we can say not enough memory, for instance. And then else we can go on and we can work with our memory. So always important to give feedback to the user, and also it's important to check that your statement worked successfully. So if the malloc statement was indeed correct, we can continue. So what you also can do is you can do the following. You can take this out, and this is going to look very similar to the idea of the sequential file access. So we can say if ptr is equal to malloc size of int is equal to null, then it didn't work. But otherwise it did. So there's different ways of doing this, and whatever suits your need, you can do this in whichever way you like. Great. So then after we have completed our program, we always need to make sure that our memory is set free, meaning to release it so that when the application is done, program finished, other applications may use that memory. So we freeing that memory for the use, or to open it up for other applications to use when this specific application is done. And that's very good programming practice, and it's not just good programming practice, it's very, very important not to forget to free your memory, your dynamic memory, after or at the end of your program. So how do we free that memory? So we say free, and we just say PTR. As easy as that. So the free statement then frees the memory allocated in this address. So PTR is storing the address of the dynamic memory. So free PTR meaning free the memory at this address, not the pointer address, but the address the pointer is pointing towards a memory space. Free that space. So that's it, ladies and gents. That's how we create dynamic memory. So just to show that we can actually store something and use that pointer now as an integer. So we can say PTR dereference that address, and that is now in the else statement, of course, because we can only do this if and only if memory was able to allocate. So we can say star pointer is equal to 5, and then what we can do is the value is %d dereference PTR. So if we run this program, if we run it, oops, there's an error because there's an ampersand. It's not a star. And we can go back, and there we go. So the value is 5. So now in fact there is memory allocated, and we stored the value 5 inside that memory space, and then afterwards we could free that pointer. Great. So we've created dynamic memory, we stored a value inside that dynamic memory, we printed out the value, and we also freed the dynamic memory. So that's the two statements that you always need to remember when we create dynamic memory. It's the malloc statement, memory allocation statement, and we need to tell the size of the memory space that we want to allocate, and then never ever forget to free that space at the end of your program. Thank you for watching, and I hope to see you soon.